Okay, now just to kind of drive home why some of this works, I just want to go through a little exercise here for you. Here we have 4 diets. All 4 diets have been balanced for roughly 90 pounds of milk. And for about 90 pounds of milk using the NRC model, that means a metabolizable protein supply of 2,800 grams. 4 diets. Forages are all the same. Energy feeds are all the same. But we got 4 different levels of predicted lysine and metabolizable protein and 4 different levels of methionine and metabolizable protein. Is there anybody here that could tell me sort of which or what the protein supplements are in these diets? Just by looking at that. Is corn low in lysine or high in lysine? Low. Corn silage, low in lysine. Corn grain, low in lysine. Corn gluten feed, low in lysine. Corn meal, low in lysine. DDGS, low in lysine. Which is the lowest? This one right here, 5.7. That's got corn silage, haylage, alfalfa hay in it. A combination of barley and corn meal in it. But a hefty amount, no soy, well, very little soybean meal. And a lot of DDGS. A lot of DDGS. A little bit of whole cottonseed in there too. If I take that 5.7%, multiply it by 2,800 grams, I get 159 grams of MP lysine. Remember, the cows require amino acids, not MP. That's just a man-made, I don't know. You know, we can't even agree on the term. Some call it digestible protein. What do they call it in France? Something else. I am not very good at French. Some call it digestible protein. Okay. Okay, so I get 159 grams. 1.9% times that is 53. I got my exact 3-to-1 ratio that NRC says is right. So those two are in balance. That's really good. But have I balanced for amino acids? I balanced for sort of for lysine and methionine here, got the right ratio. A lot of people out in the field today think they're balancing for lysine and methionine because they got a 3-to-1 ratio. Oh, great. But with this diet, only 159 grams of MP lysine. What's this diet right here? Well, that's more or less the diet that I kind of like, you know, because I like soybeans and soybean meal. So that's got soybean meal in it and soy plus. It could be amino, amino best or whatever. Any of those. But remember, soybeans are high in lysine. That's why we like to feed it to pigs. That's why we like to feed it to cows. It's high in lysine. But it's atrociously low in methionine. It drove methionine even lower. Yeah?
Are there any grains that are high in methionine?
Grains that are high in methionine. Yeah, corn. But it's low in lysine. Yeah, see, here, high corn. Notice corn higher in methionine apparently than soybean is. But what's going to be limiting milk protein synthesis up here? Is it going to be lysine or methionine? What's going to be limiting, sir? Yeah, methionine. That's the most limiting amino acid here. It's a whole lot more limiting than lysine. I got a 3.8 to 1 ratio. Cows. Here I was spending money on protected soy at the University of New Hampshire, and I was wasting my money. Because I thought, you know, that get that high lysine was important, but I forgot about my methionine. This diet right here is the very same diet as this one, as now I just chucked a bunch of protected methionine at those cows to get my right lysine to methionine ratio. Now I go from 48 to 60 grams, and now up here probably only 144 grams out of that 179 could be used for protein synthesis, because that's 3 times that, right? It's 144. Okay? And this, I took out the protected soy and put in a little bit of JBS United blood meal. And I got it up to 6.6. I took out the protected soy, but now I had to feed a little more protected methionine. Oh, that hurts. You think that hurts, huh? Well, but I'm not up at 7.2 or 6.9 and 2.3, 2.4. I haven't got up to that optimum yet. And I just told you not too long ago what field nutritionists and dairy producers are telling me the optimum is somewhere around here or somewhere in between these two. Obviously, they're all feeding a protected methionine supplement or Metasmart, one of the two. Okay? Now you look at these values over here and you say, huh, sometimes my cows give more milk than NP allowable milk according to my nutritionist model, and oftentimes they give less. I wonder why. Well, it could be because you're down here instead of somewhere up here in the middle. Oh, can my cows give more milk than NP allowable milk according to my model? Yeah, if you're up here. So look at these values here. Do you think these cows here will give more milk and more milk protein than those cows? Well, of course. These are nutrients. Crude protein is not a nutrient. That's something labs analyze for nitrogen, multiply by 6.25 and tell you it's crude protein. It's a crude estimate of a collection of amino acids and NPN compounds. Okay? But this is what the cows require. Now, how much more milk and milk protein will these cows give? That's a question. Do you all remember back in 2001, 2002 when milk prices went below $10 a hundredweight? It happened at the University of New Hampshire too. What wasn't said earlier is I was faculty coordinator for farm operations while I was there, and I was responsible for the farm budget. And remember I said I'm pushing 6.6 and 2.2 in my herd, and all of a sudden milk prices fell, and the phone is ringing off the hook every day and saying, Dr. Schwab, we've been balancing for amino acids, but we don't think we can afford this anymore. Like, we got to stop doing this. And I'm thinking to myself, ooh, maybe I better evaluate this too. So I had a PhD student at the time, and I said, chuck a lot of diets into the NRC model from the scientific literature. And he kept chucking them in, and he said, when can I stop? I said, how many you got? 250. I said, no, keep going, keep going. Because I wanted to look at model predicted MP flows, MP methionine flows and MP lysine flows on studies where milk production went from basically zero production all the way up to the highest production recorded in Journal of Dairy Science. And he did that. And we got dose response plots relating grams of MP methionine flow and MP lysine flows to the small intestine, and we could look at the relationship between those and milk yield and milk protein yield. I could show you those plots, but they're very busy and I don't want to bore you with that. I just want to talk to you and look at you, okay, and not have you looking at the screen. That's what we did. So we took those equations that we developed and we predicted milk yields and protein yields from those four diets that I just showed you. And here they are. If I use my lysine equations, I got these values, and if I use my methionine equations, I got these values. Wow. Now I have more confidence in these values and these values, in other words, the values generated with the methionine equations here, because we had a lot more data in our database. But what's that telling us? The cows require grams of lysine and methionine, not MP. That's one thing it's telling us. And it's telling us that that at higher levels of production, the cows need more methionine, more lysine. And I said, wow, this is really good. This is really great. Now I can decide, oh, I'm going to take the blood meal out of my diet and the protected methionine out of my diet, and I'm going to make a substitution, and I'm going to see how it affects milk yield and protein yield. And butterfat yield, which I'm not showing you. And you know what my conclusion was when we were getting $9.78 per hundredweight of milk at UNH was? At that time, now feed costs were less, mind you, to keep balancing for lysine methionine. So we never stopped. We never stopped. Because the economics told us, don't stop. That's why we got to have stuff like this built into the model. Another thing that we have realized over the years, as we go from here to here, What did I say about milk protein concentrations? Will it go up or down or stay the same? They're going to go up. The mammary gland likes balance. Cows like balance. Rumen bacteria like balance, consistency. We talked about that. The mammary gland likes balance of nutrients, because the more balanced the nutrients presented to the mammary gland, the more efficient that mammary gland is. That's been shown in vitro and in vivo. Okay? So what happens as we go from a poorly lysine and methionine balanced diet to one that's better balanced? Milk protein goes up. Research shows it. Field experience shows it. Will this show it? This is all calculated data from actual production data using NRC model generated MP lysine and MP methionine flows. So all I have to do is take these milk yields and divide it, these milk protein yields and divide it by milk yields, and I'll get milk protein percent, won't I? Now, I was a little anxious about doing this here years ago. So what if this doesn't work? Well, that's what happened. Look at that. It works. What's that telling us? What's that telling us? The better balanced our diets are for lysine and methionine in this case, the better amino acid balance they are, milk protein concentrations go up. That's exactly what we see in the field. And when we do this, there's something else we see in the field, and that's milk yield goes up at the same time. Wow. That speaks to the importance of efficiency for the mammary gland, the rumen, and the entire cow.